Right, we are actually looking at the so-called geometric sequences and series. There are specific formulae that we need to focus on and learn. The Tn formula, which is AR to the power n minus 1. You have the Sn formula, which is A into 1 minus r to the nth power divided by 1 minus r. This formula here works when the constant ratio is not equal to 1. We have the summation to infinity, which is a divided by 1 minus r, where the constant ratio has its modulus or its absolute value strictly smaller than 1. We also will be looking at what we call the quadratic sequences. And the general term for quadratic sequences is Tn equals an squared plus bn plus c. Okay, these are the formulas that we shall focus on when we study geometric sequences and series in conjunction with what we call the quadratic sequences and series. Now, the first thing we shall focus on is an example. In this example, we are given the geometric sequence with the terms 27, 9, 3, and so on. Determine a formula for Tn, the nth term of the sequence. Why does the sum to infinity for this sequence exist? Determine S infinity. So now, what do we need here? We need to solve this particular example, then focus on the given sequence. We have already been told that it is a geometric sequence. What are the terms? 27, 9, and 3. So we list. We list the terms down. Right, we're looking at part A. The sequence given has the terms 27, 9, 3, and so on. Right. So we're interested now in actually, because what does the examiner want? In answering the question, we need to find a formula for Tn. Right. The nth term of the sequence. What is Tn? Right. Tn is the same as AR to the n minus 1. Right. So we actually now need to write something here. Right. What is the first term? The first one is actually 27. What is the second term? The second term is a 9. What is the third term? The third term equals 3. And now we find T2 over T1. What is T2? Is actually 9. T1 is 27, which is 1 out of 3. So you have T3 out of T2. T3 is 3 out of 9, which is 1 out of 3. So, which means that we are interested in finding the nth term. What is the first one? Right, A is the first term. The first one is 27. The constant ratio is 1 out of 3 and is raised to the power n minus 1, like so. Okay, so this is the answer to the question, but the answer can be written in many ways. For example, the number 27 can be written as 3 to the third power multiplied by 3 to the minus 1 into n minus 1. Right, so that Tn is the same as, right, you have 3 to the power. Now, there is a 3, if you distribute here, it's going to be minus n plus 1. And this is the same as 3 to the power. What is 3 plus 1? It's actually 4 minus n. And therefore, this is exactly the formula for Tn. In other words, for the A part, we then say our Tn formula is 3 to the power what? Is 3 to the power 4 minus n. 3 to the power 4 minus n, and we're done. Right, if you look at the B part, if you look at the B part, yeah, so we are determining a formula for Tn, the nth term of the sequence. Why does the sum to infinity for this sequence exist? Why does the sum to infinity? Why does the sum to infinity for this sequence exist? Right, so the sum to infinity exists if the common ratio or the constant ratio is strictly smaller than 1. You can see here The constant ratio, obviously here, it is clear that the constant ratio is 1/3. Right, so because T2 over T1 is 1/3. T3 on T2 is 1/3. And therefore, this is the constant ratio. The constant ratio is 1/3. So that in part B, the constant ratio is 1/3, and this implies that we can be able to get its absolute value. And the absolute value of 1/3 is actually just 1/3, and this means that the common ratio is has the modulus 1/3. 1/3 is strictly smaller than 1. Hence, hence, um, we come here to answer the question and respond to this. Why does the sum to infinity exist? Sorry, now we then say, hence the sum to infinity exists if, exists since, right, exists since, right, exists since this is smaller than 1. Right, sorry, so that the geometric series, so that the geometric series converges. So that the geometric series converges. Determine now the sum to infinity. The sum to infinity. So, right, in part C, to find the sum to infinity, which is exactly this. 1 minus r. It is exactly 1 minus r, but the modulus is strictly smaller than 1. So, which means we have this. Okay, so now the couple of things we need to consider. But this is 2793. Right, so you have 27, you have 9, you have 3, this is the sequence and so on. So the first term is 27 divided by 1 minus. We've seen that the common ratio, the constant ratio is 1/3. So that you have 27 divided by, what is 1 minus 1/3? It's actually 2/3. And therefore, the sum to infinity is the same as 27 multiplied by, okay, you are dividing by this, so it means you are multiplying by 3/2. And therefore, what is 27 by 3? 27 by 3, which is exactly 81/2. And therefore, the sum to infinity is exactly this. It's exactly 81 out of what? It's exactly 81 out of 2. We continue to look at more problems that are extremely important. But the next exercise is about more geometric sequences in series. And here comes another example. An example. Right, in this example, we need the following. We need to consider, so in this example, we're saying consider the geometric sequence. The geometric sequence with the terms x and then x plus 3, and then 3x minus 1, and so on. So at this point, you need to be able to calculate the value of values of the common ratio. Right, and the common ratio is R if this is greater, if the common ratio itself is strictly bigger than naught. And now the examiners here decided to allocate exactly 7 marks here for this question. Let us solve this question. We prepare a solution to this one. How do we prepare a solution to this? Right, we are asking the question, consider the geometric sequence x plus 3, then 3x minus 1. Calculate the values of the common ratio. Right, so to find the common ratio, we need to note that T1 is x, T2 is x plus 3, T3 is 3x minus 1, and so on. And then if T1 is x, T2 is x plus 3, T3 is 3x minus 1. And then you apply here T2 over T1, which is this T2 is x plus 3 and divided by T1 like this. And then now we need to be able to solve this particular question. And so what then are we able to achieve here? We're able to realize, therefore, that this is, if you divide x by x, so you can divide x by x, and then you divide 3 by x. So if you divide x by x, you get a 1 plus 3 over x. Right, and then now you have a T3 over T2. What is T3? Is x minus 1? Right, so yes, you can do that. But I feel that there is a nicer way to do it. Very easy. Than to write too many things. Let me cut out a lot of the writing to make things a little easier. Okay, right. The best would be to just say T2 over T1 must be equal to T3 out of T2 because it's geometric. Right, it's a geometric progression. And then now you have the x plus 2, which is x plus 3 divided by x. T3 is 3x minus 1 divided by x plus 3. Right, you cross multiply these things here. And if you cross multiply these things, you get x plus 3 squared, this by this. And then now you have x by this, which is x into 3x minus 1. Right, and you square this. If you square this one, it becomes x squared. You square the x, then x by 3. X times 3, which is 3x by 2. It is exactly 6x. Now, 3 squared is 9 equals, you have x by 3x, which is exactly 3x minus x. Right, and which is exactly x squared. Now, the 6x, now you have here, what? Okay, this one is going to be exactly 3x squared there. Okay, right. So we continue to analyze this. And now you have x squared minus 3x squared minus x squared, which is 2x squared. And then now you have minus x minus 6x, which is minus 7x minus 9 equals 0. So if you have 3x squared minus x squared, which is 2x squared, minus 7x minus 9 equals 0. So you have 2x squared. You have 2x squared minus 7x minus 9 equals 0. Right, so let us actually factorize this. The factors of 2x squared, okay, there are a couple of ways to factorize this, and so you can look at things that way. But an easier way would be to say multiply 2x squared by minus 9x, and you get minus 18 x squared, so that you look for two expressions whose product is minus 18x squared, but whose sum is minus 7. What are those? Clearly, those are minus 9x plus 2x minus 9. Because you first, okay, this technique, you first multiply 2x squared by minus 9. 2x squared times minus 9 is minus 18x squared. So you take the minus 18x squared, you look for two expressions whose product is minus 18x squared, whose sum is this, which is minus 9 plus 2. Okay, we continue. Okay, here we factor out x, which is 2x minus 9 plus 2x minus 9. Right, so this is 2x minus 9, x plus 1 equals 0. So what is the meaning of this? Right, so we continue. And then now you have x equals 9 out of 2, or x equals minus 1. So after this, then we have got the values of x, but do they work, these values of x? We need to check. Right, for example, now you have the x equal to 9 over 2. Okay, so this x equals 9 over 2. And then now, which means that you have x plus 3, 3x minus 1. Right. You have x plus 3, then you have 3x minus 1. You substitute the 9 over 2. So here it's going to be 9 over 2. Here you substitute the 9 over 2 in the place of x, and then you add 3. Here you substitute the 9 over 2, you subtract 1. And then this is 9 over 2, and then here this one is 6 plus, which is 15 over 2, and then this one here is 27. 27 minus 2. What is 27 minus 2? Which is 25 out of 2. Let us check this here in terms of T2 over T1. T2 is 15 out of 2. You divide by T1, which is 2 out of 9, which is T2 out of T1 is exactly, okay, divide by 3, which is 5 out of 3. T3 out of T2. T3, which is 25 out of 2. You divide by T2, which is this, which is T3 out of T2, which is 2 cancels, 5 goes how many times into, it goes 5 times and goes 3 times into 15. Okay, so and this here becomes the common ratio. So, but let us check now also when x equals minus 1 into this. So you have x plus 3, and then you have 3x minus 1. Okay, when you put the minus 1, it becomes minus 1 plus 3, which becomes 3 to the x minus 1, which is minus 1, 2, and then minus 3 minus 1, which is minus 4. Right, if you divide, for example, and you say T2 over T1, T2 is 2 over this, which is minus 1, minus 2. Right, so you have a minus 2 here. And then you have T3 out of T2. What is T3? Is minus 4 over T2, which is minus 2, meaning there is indeed a common ratio. Here the common ratio is minus 2, and it makes this one indeed geometric. But also here you have that the common ratio is 5 out of 3, and this really confirms the fact that these are the correct values of x. Now, there are a couple of things that we need to consider, right? We need to look at, because you have to consider the geometric sequence, this calculate the value of values of x, right? If the common ratio is positive, so we want the common ratio to be positive. So let's just check right now. So here the common ratio is negative, and this is also negative. So which means therefore that we're not going to accept this one here. So x can only be this, right? So we don't accept that because the common ratio must be positive. And here the common ratio is 5/3, which is positive. And therefore we're going to accept only one of the solutions. We're going to accept this one. And here this one is said to be inadmissible. Inadmissible. Right, here is another exercise. This one is a home activity for you because I must give you something to try. Right, here is the home activity. Right, in this home activity, you need to try and solve this problem. And then you're going to send me the answer on WhatsApp so that I can check if you are right or wrong. And then we shall see what to do. Here is this. It says the following sequence. The following sequence is a combination. So there are those sequences that are combinations. So this one is a combination of the arithmetic. So sometimes, because last time I spoke about arithmetic, I think you were here online, arithmetic sequence and geometric. In geometric sequence. Right, and then it is having the terms 5, 5, 15, 10, 25, 20, 35, and so on. Here comes the first question. A, write down the next two terms. B, calculate T42 minus T41. C, determine the sum of the first 50 terms. Okay, this one is a home activity for you. The following sequence is a combination of the arithmetic sequence and geometric sequence. Write down the next two terms. Calculate term 42 minus term 41. Determine the sum of the first 50 terms. Right, I want us to continue and look at more other questions. I'm going to make this video available for you to watch, okay? So that you can take down the questions as well. But I want us to right now do another question on what we call the quadratic sequences, just an example on the quadratic sequences. And then I'm going to give you a chance to try this homework, and then we shall take it from there. I'm going to give you the answer to this. We can even get back online if you are very energetic, but also we need to do more science and need to do more uh, life sciences as well. Okay, more physical sciences and more life sciences. So we look at another example. Right, so as we look at this example, the couple of things that we think about here. So these things that we think about are very, very important for us. So let's see what we can do. Let's look at this exercise. Okay, it's this example. So this one, I'm going to do it with you now. Right, because it is extremely important for us to actually try this one here. Right. Yeah, here's a nice one. Consider the quadratic. The quadratic number pattern. The quadratic number pattern, which is minus 145, minus 122, minus 101. Okay, part A, the question says write down the value of T4. B, show that the general term of this pattern, right, show that the general term of this pattern or of this number pattern is Tn equals minus n squared plus 26n minus 170. Right, and there is another question, part C. Between which two terms of the quadratic number pattern will there be a difference of minus 121. Part D, what value must be added must be added to each term. Each term in the number pattern. In the number pattern. So that the value of the maximum term in the new number pattern formed will be 1. Let's look at the solution to this. Solution. Right, so here we're really saying consider the quadratic number pattern this. And the question we're asking right now is write down the value of T4, the fourth term. I'm sure that that one is very, very straightforward, and you can be in a position to find the fourth term here yourself. But let's take a look at what can be done here in this case. Right, so we need to first take into account the terms that constitute this particular sequence, but also get to think about exactly what is happening in part A. So we have minus 145, minus 122, minus 101, part A. Right, so we have minus 145, minus 122, minus 101. Okay. Now, what is happening here? What is the difference between these two? So minus 122 minus into minus 145 is 23. Minus 101 minus into minus this is 21. Right, and therefore the common difference here is minus 2. Okay, you can continue with you can continue the pattern here and say this is minus 2, but you add this to that. Okay, you say 22 minus 2 is 21. 21 minus 2, you get, for example, a 19, and you continue like so. So you can see that if you add these to that, you get this. And if you add these to that, what do you then get? So you have 19 minus 101, which is minus 82. Right, and this means, therefore, that we needed the fourth term, and now this is exactly the fourth term. So this is the fourth term, so which means, therefore, that the fourth term is minus 82 like this. Okay, so we're done with that one. Show that the general term of this number pattern is this. So we need to just show the general term. So we solve part B. Right, looking at part B of this, we first write down the progression, which is the quadratic progression in terms of 145 minus 122 minus 101 So which means that we have this, which is exactly 23, which is exactly 21, and we find the difference here, and it's minus 2, and you continue. Okay, it's going to be minus 2 again, so 22 minus this, it's this, and you subtract here, you get 19, and you have this with this, what do you get there? You get exactly 82. So what does this mean? It means that here you always say 2a is this. This one becomes 3a plus b equals this. And so now here we say a plus b plus c equals that. All right. And so if you look at these carefully, you're able to realize that if 2a equals minus 2, you divide both left and right by 2. And the conclusion, therefore, is that a is minus 1. Okay, so if that is the case, part B, you have 3a plus b equals 23. Right, so you have 3a plus b equals 23, which is 3a is minus 1 plus b equals 23, which means b equals 26. Okay, this is minus 3 like that. And then now you just have one more. The a plus b plus c part equals the first term here, which is minus 145. So you write that this one is minus 145, meaning the a is minus 1, the b is 26 plus c equals minus 145, which means therefore c equals, okay, 26 minus 1 is 25. You bring it across, it becomes exactly minus 170. And hence the observation therefore is that Tn equals an squared plus bn plus c, which means you have Tn equals minus 1. So this is going to be like minus n squared plus 26n minus 170. You see, the question was, show that the general term of this number pattern is this. So minus n squared plus 26n minus 170. So let's check. Minus n squared plus 26 minus 170. Okay, so you have part C. Right, in part C, between which two terms of the quadratic number pattern will there be a difference of minus 121? Right, so let us look at this. Between which two terms of the quadratic number pattern will there be a difference of minus 121? So in other words, now you want to find the difference. And the difference of minus 121. Let us look at this and look at this very, very carefully. So in other words, at this point, we need to look and think. And obviously think of the approach that we're going to use to solve this particular problem. Right, and what do we actually do? Because if we're then saying between which two terms of the quadratic number pattern would there be a difference of minus 21? Part C. Right, so in other words, obviously we are looking at the fact that we have the general term that has been given to us. And we have the pattern minus 145, minus 122, minus 101, and so on. Okay, the difference, this minus that is 23. This minus that is 21. The difference here is minus 2. And then here, what do you have here? Right. So in the same way, you're able to see that if I just move this a little bit down. Right. So able to see that you have the common difference of -2 here. And if you combine these, you get this. If you combine these, for instance, you'd get a 19 here, and so on. And we have seen that the same here, and you'd that would produce, for instance, a -82 there, a -82. Now let's look and think, but very carefully in terms of what this means and what the implications are of this, because it means a couple of things. But we want to know, according to this question, between which two terms of the quadratic number pattern will there be a difference of this? So you need to look at the number pattern. The difference between the terms of the number pattern terms, the difference between successive terms is this, which is, and this forms a sequence that has a common difference, meaning this one is arithmetic. Right, it is arithmetic. Right, being arithmetic as it is, it means a couple of things, but it means that you need to um you need to just take this and find a pattern here. You need to be able to find a pattern and be able to find the formula that you can use here to analyze this. And the question becomes, therefore, what is the formula here? What is the formula here? So because this one is arithmetic, you need to use the formula Tn equals a plus into n minus 1 into d. Right. So the first term here becomes 23 into n minus 1. The common difference is -2, which is 23 minus 2n plus 2, which is minus 2n plus 25. So which means that you have already got this. But this is the general term here. So if the general term is this, you need to therefore consider what needs to be done here. So the general term being this, it means that you need to consider those terms whose difference is -21, meaning this term here is -21. And that means that in the part C, you have the following. So you have the Tn, which equals exactly minus 2n plus 25. Plus 25. And this is equal to what? It's equal to minus 121. Right. So this is minus that, which is minus 146. Right. So if you have this, then you have minus 146. You divide by -2, you divide by -2, which means n is is actually 73. Because 146 divided by -2 is actually the same as 73. And that means, therefore, if n is 73, right, it means, therefore, that it is between. It means, therefore, it is between term number 73 and term number 74. Okay, because you're getting n is 73, it means therefore here is between term number 73 and that. Because, for example, if you get the position of this term is term number 1, it's between what? It's between 1 and 2. Term number 2 in this particular progression, term number 2 is the difference between term 2 and term 3. So, what is the meaning of this? The difference between term 2 and term 3 is term 2. So in other words, if you get term 2, then it must be term 2, term 3. So if you get a 73, it must be between T73 and T74. Next question. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern will be 1? Okay. What value must be added to each term in the number pattern so that the value of the maximum term in the new pattern formed will be 1? Okay, let's look at these there and analyze what exactly is being asked here. Let me see what we're asking exactly here in terms of whether, right. Yeah, that is perfect. Okay, right. So let's solve part D. Right, let's look at part D. But in looking at part D, therefore, we know that Tn is equal to what? It's equal to minus n squared plus 26n minus 170. Which means, therefore, that n is minus b over twice a. Right, the minus b, which is minus 26 over twice into this, which is exactly 13. So which means, therefore, this is exactly 13. So now, if it's exactly 13, we're asking the question, right. So in other words, this is because this minus here in the quadratic, it means that you have a shape that is gonna have a maximum. Right, if the shape is gonna have a maximum vertex, the maximum is gonna occur at n equals 13. But now, if you look at what the examiner wants, they're asking the question, what value must be added to each term in the number pattern so that the value of the maximum term in the new pattern formed will be 1. So let's analyze this question carefully and see what needs to be done here. Right, so in view of this question, right, what must be added? For example, so it means that the maximum, right, must be, the maximum is going to occur at n equals 13, and that means, therefore, if you find term number 13, okay, we're finding this because the examiner is saying again, so that the value of the maximum term in the new number pattern formed will be 1. So we need to find the value of the maximum term. Right, so the value of the maximum term is going to occur at 13, which means is minus 13 squared plus 26 into 13 minus 170. So which means you have this. Okay, so it's minus 1. Right. So it's minus 1. So what number can we add to minus 1 so that the maximum value is 1? Here. What value must be added to each term of the number pattern so that the value of the maximum term in the new number pattern formed will be 1? The value of the maximum term will be 1. So we must add 2. Right, so hence 2 must be added. Hence 2 must be added. Right, that is, if you add, you take the minus 1 and you add 2 to it, you'll get 1. And this is going to be the maximum term. Is going to be the maximum term like that. Okay, just to note exactly that is a point we're raising as an observation. So let's continue. Right, we are continuing with our analysis of this particular problem here. Right, let's continue with our analysis of this particular problem and see what next we can achieve. Okay, I'll just be cleaning up this mess quickly. I'll just be cleaning up that mess there. Okay, and so I've given you homework on the combined series. So I'm interested in you trying to get sort of give the answer to that one. So right, so think about that carefully and see what we can do there. Okay, I need to clean this up, and this will pretty much be um, sort of the last discussion we have. So the last example, to be the last example we have. Right, to be sort of the last example we have. So just take note of these and make sure that you understand these very much in the make sure that your understanding of these is on par. Right, we're done. I'll just be um I'll just be finishing this off. All right, just be cleaning my board. I'll just be cleaning my board now. I'll just be cleaning my board right now. I'll just be cleaning my board right now. Okay, that's interesting. That's very, very interesting. Never mind. Right, we're cleaning up. Right, cleaning up my board. So you just need to try that exercise I just gave you now. Right, we are done. Need to clean my board up. Right, the system sometimes can just act up, so we're done. That's fine. Just need to clean these up, this little mess here that's created, and we're good. Right, so now, when I was saying is the maximum term there. So, right, so we're done, and I'll see you again. Okay, so try that exercise I gave you, the home activity. Here's the home activity I gave you. Here. Right, here's the following sequence is a combination of the arithmetic sequence and geometric sequence. Write down the next two terms, calculate this one, determine the sum of the first 50 terms. Okay, we're done. Thank you. Please try this and send me some screenshots. Okay. Thank you. Goodbye.